The following question was asked from transmission control protocol, and the question is very simple. Node X has a TCP connection open to node Y, and the packet from X to Y go through the intermediate IP router R. Ethernet switch S is the first switch on the network path between X and R. Consider a packet sent from X to Y over this connection. Which of the following statement is are true about the destination IP and MAC address on this packet at the time it leaves X? Correct. So if you will see, the destination IP address in this IP address is R, the destination IP address in IP address is Y, the destination MAC address is the MAC address of S, and the destination MAC address is the MAC address of Y. Just a theoretical question. Packet is sent by X, it will contain the destination IP address, it will contain the destination IP address, and it will also contain destination MAC address. Correct. Now, since this particular destination host is on another network, and due to that, packet will be forwarded to the default gateway, which is R, right? Now, we can say that therefore the destination MAC address, media access control MAC address, that is the physical address of that particular device, will initially will be of R, and destination IP doesn't change, and it will always be that of Y. So the destination IP is definitely of the Y, it will not change. Thus option B is one of the correct answer. And not bridge and switches does not modify the MAC address. Bridge and switches does not modify the MAC address in a packet. They just forward. They just forward. Right? So in that case, the destination MAC address is the MAC address of S. So it will not change. So I hope option B as well as option C both are the correct answer for this particular gate question. I hope it is clear. Following question was asked from computer network from IPv4 topic for 1 mark, and the question is as follows. Which of the following statement about IPv4 fragmentation is are true? So if you will read the options, the option is all about the fragmentation and reassembly. The this particular question is all about fragmentation and reassembly. Now, the fragmentation of IP datagram, it depends. So if we are performing the fragmentation, then fragmentation of IP datagram, if size is greater than MTU, then any intermediate router can perform. At any intermediate router we can just perform the fragmentation if the size is greater than MTU. And as a part of reassembly, if a reassembly of fragments can be performed only at the destination, we can only perform the reassembly only at destination, but not at the intermediate part, not at the any intermediate router. So if you will look at option A, here it is writing that fragmentation only at source, so it is false. Option B, fragmentation at any IP router, it is true, because here already the condition given, the size of data is exceeding the MTU. Option C, the reassembly of fragmentation is performed only at destination, conceptually it is true. And option D is reassembly of fragments is performed at all intermediate router along the path from source to the destination, so it is false, just contradicting C. So B and C is the correct answer for this question. I hope it is clear. The following question was asked from IPv4, and the question was asked for 1 mark. The question is as follows. Which of the following field of an IP header, Internet Protocol header, is are always modified by any router before it forward IP packet? So whenever any router forward the packet, whenever any router forward the packet, so at that time in IP header there might be source IP address will be there, protocols are there, TTL, time to leave is there, and header checksum is there. So source IP address remain unchanged. Source IP address remain unchanged. It will be unchanged, right? And because this source IP itself is responsible for identifying the original sender, and if it is going to be changed, then how we are going to get the answer that from which data set we have sent it? So it is not going to be changed. Thereafter, option B is protocol. So protocol is just indicating the type of data. It is indicating type of data. For example, it is TCP, transfer control based data, or user datagram protocol, what it is, correct? And it is also we cannot alter. Thereafter, TTL, time to leave value, it is decremented by 1. It is decremented by 1 by each router that forward the packet. So time to leave decremented at each router. Thus, this particular field will always be modified. And option D is header checksum. So as you know that we are decrementing TTL, time to leave, at each router. So corresponding header checksum will also recalculated based on TTL. Thus D will also modify. So option C and option D is the correct answer for this question. I hope it is clear. The following question was asked from CIDR, classless interdomain routing, for 2 mark, and the question is as follows. Which one of the following CIDR prefixes exactly represent the range of IP address 10.12.2.0 to 10.12.3.255? So if you will just look here, that the range defined by the question is 10.12.2.0 to 12.10.12.3.255, right? 10 dot, the range is 10.12.3.255, right? Now the question is which one of the CIDR prefixes exactly represent the range of IP, exactly represent, getting it? So how I can write 10.12 dot this 2 in binary form I can write like 0 0 0 0 0 0 1 0, correct? And then this 0 I can represent as 0 0 0 0 0 0 0 0, right? Now this particular range, if you will see, that is here 255. So if I want to represent this, I can represent it with this way, that is 10.12.3. So this 3 I can write in the binary form like 0 0 0 0 0 0 1 1 dot 255, means combination of all 1 1 1 1 1 1 1 1 1, correct? Now if you will see here, if you will just see here in this particular picture, that how many bit common prefix are here. So if you will see that last 9 we are getting 0, this last 9, because these are 8 bits and this is 1 bit. 8 plus 1 is 9 bits. So what we are getting, we are getting 9 bits at end, they are all 0 to all the comparative 1. So what is the common bit practice? What is the common bit practice? So 32 minus 9, if you will see, it is 23. So 23 should be there. So only one option is there which is having 23 bits common prefix. The option A is the correct answer of this, because in B it is 24, it is 22, it is also 22. Only one option is here. Option A is the correct answer for this question. I hope it is clear. Following question was asked from transport layer TCP, transmission control protocol, for 2 mark. The question is as follows. Consider a TCP connection operating at a point of time with the congestion window of size 12 MSS, that is maximum segment size. When a timeout will occur due to packet loss, Assume that all the segments transmitted in the next two RTT round trip time are acknowledged correctly. The congestion window size in MSS during third RTT will be, right? So you know the congestion window size is given 12 MSS, and whenever threshold will occur, whenever threshold will occur, then threshold will occur as a CWND, that is congestion window of size this, and with timeout occurred due to packet loss, assume that all segments transmitted in next two RTTs, right? So we can divide it with 2 and we are getting 6 MSS, right? So the thing is like that, the congestion window of 1 MSS will be sent, and in one round trip time we are going to get the acknowledgement. After that we are going to send second MSS, and then in second RTT, that is second round trip time, we will get the acknowledgement of this packet, and thereafter this particular packet will again send, that is third round trip time, that is third RTT will be done on 4 MSS. So we will get acknowledgement here. So you know that the TCP congestion control enter into slow fetch from here onwards, and CWND is lesser than threshold. So this particular congestion window is increasing one by one. Here 1 RTT, then 2 RTT, then here it would be in the third RTT. In third RTT we are sending 4 MSS, right? So in slow phase, CWND, that is congestion window, will almost get doubled at every RTT. So the question here is all the segment transmitted in next to RTT are acknowledged correctly. The congestion window size in MSS during third RTT. So in third RTT, the congestion window size is 4. So 4 is the correct answer for this. 4 is the correct answer for this NAT based question. I hope it is clear. The next question is from collision detection technique, and the question is as follows. Consider an Ethernet segment with a transmission speed of 10 to the power 8 bits per second and a maximum segment length of 500 meters. If the speed of propagation of a signal in the medium is 2 into 10 to the power 8 meter per second, then the minimum frame size in bits required for collision detection is what? This question was asked as a numerical answer type question for 2 mark. Right? So let's try to solve this. Here we are having bandwidth, that is 10 to the power 8 bits per second. We are also having distance, that is 500 meter. We are also associated the velocity. Velocity is also given, and that is 2 into 10 to the power 8 meter per second. Now you know for Ethernet transmission time, TT is greater than or equal to 2 into TP, that is propagation time. So where TT is transmission time, TP is propagation time, and the formula for TT is nothing but Fs divided by bandwidth and greater than or equal to 2 into distance divided by velocity. Correct? So Fs is nothing but fragment size. So this particular thing I can write it like f of s is greater than or equal to 2 into d divided by v, and the bandwidth going to the right side, so it will be multiplied like this. Now I am going to utilize this formula and I will just substitute the value. So after substituting the value of bandwidth, distance and velocity in the formula, I will get the fragment size is greater than or equal to 2 into the distance was 500 meter, bandwidth was velocity was 2 into 10 to the power 8 meter per second, and the bandwidth was 10 to the power 8 bits per second. So if you will cancel them out, unit is also got cancelled like this, and at the end this per second got cancelled. 10 to the power also get cancelled with 10 to the power 8. So the fragment size is greater than, it should be greater than 500 bit. The fragment size should be greater than 500 bit. So 500 is the correct answer for this NAT based question. 500 is the correct answer for this NAT based question, right? So we require at least 500 bit fragment size. This is the correct answer for this question, which was asked for 2 mark in NAT. I hope it is clear.